Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 1, question 3. The formulas used are included in the video after the question. The question is also posted in the description box below. Let's get straight into it. Okay, first off, we have a shaft. We have a round shaft. Now, on the shaft, we have a flywheel and a pulley. So, each with different lengths across. So from here to there is 1.5 meters. From there to there is 0.5 meters, and from there all the way to there is 3 meters. And it's supported by 2 bearings. Just consider these as bearings. Consider this here as a bearing, and that's a bearing. At this point, just consider them like that. Now our question states, a solid shaft supported by 2 bearings, which are 3 meters apart, is used as a drive shaft with a flywheel and a pulley on the shaft. The weight of the shaft is 500 newtons per meter. So weight 500 newtons per meter. The mass of the flywheel is 200 kgs. So mass flywheel is 200 kgs. And is mounted 1.5 meters to the left from the left bearing. The pulley is mounted 500 millimeters. So the pulley is mounted 500 millimeters from the left bearing. And transmits power by means of a belt drive. The tight side tension, so T1, is 2,500 newtons. The slack side tension, which is T2, is 500 newtons. The effective diameter of the pulley is 800 millimeters. So diameter, effective diameter is 0.8 meters. Assume the belts are vertical and downwards and parallel. Now, what they want is the reaction only at the left-hand bearing. Never mind the right bearing, they only want the left-hand bearing. Right, then they want the maximum bending moment if it occurs at the pulley. Then they want the maximum torque transmitted, and then the diameter if the shaft were hollow. They want the diameters of the pulley. They want the diameters of the shaft. If the principal stress is limited to 75 megapascals. And the inside diameter is 60% of the outside diameter. Okay. So how we're going to do this is, first of all, we're going to take the reaction at the left-hand bearing. And this is how we do it. If you remember simply supported beams and how to take a bending moment, that is exactly what we're going to do. So in this particular case, we have, now, this is all, so you say your clockwise equals your anti-clockwise. Your clockwise equals your anti-clockwise. So, what that'll say is that this support is going clockwise. The rest are all going anti-clockwise. So, what we're going to say is that RL to get to RR is 3 meters. So we measure from RR because we want to take we're taking bending moments about RR to get RL. That's how we do it. So all of this is going anti-clockwise, and that is going clockwise. So what we'll have is RL times the 3 meters equal. Now, we're going to take the weight of the flywheel. So the weight of the flywheel is 200 times 9,81, which is equal to 1962 newtons. Okay, so let's take the flywheel. Now, from the left-hand bearing, it is 1.5 meters. So if it's 1.5 meters, then from RR, so 1.53 minus 1.5 will give us 1.5. So 1962 times 1,5. Now we plus the pulley. The pulley will be 2,500 plus 500. So 2,500 plus 500, which will give us 3,000. 3,000 times. Now, 3 meters minus 0,5, which is 2,5. 2,5. Now we've got to add the weight of our beam. Now how the weight of the beam works is 500 times 3, because it's 500 newtons per meter. So 500 times 3 meters, which is the length of the beam, times, because it's going to become, instead of a UDL, it's going to become a point load. So then times by 1,5. So that's exactly at the halfway point. So all this will equal, now all we have to do is put this in our calculator and get our values. So we'll get these values first and then divide by 3. So let's do that. Bracket 1962 times 1,5 plus 3,000 plus 500 times 3 times 1,5 equals RL times 3, which is 12693 divided by 3, divided by 3, RL divided by 3 equals 4,231 Newton. Now we'll need this. So RL is equal to 4,231 newtons. Okay, now 3,2. Now we need M. Because they want the bending moment at the pulley. So how this will work is we go from the left-hand side, because that's the value that we have. So we have M equals 4,231 times 0,5 minus, now we're we're going to take the weight of the beam into account. So 500 times 1 times 0,5, because that is how much the pulley is. So the pulley is 0,5 meters away from your RL. So that is why the 500 newtons per meter, so 500 times 1, which is for 1 meter, times 0,5. You always have to do this. Put that 1 in. It's part of the calculation. You always have to do it. It makes your answer more accurate. So we have 4,231 times 0,5 minus 500 times 1 times 0,5. And our answer is M1865,5 Newton meters. So M 1865,5 Newton meters. Next part is we want to find the maximum torque. Now, if you remember, if you've done mechanotechnics for N5, you will remember that torque in a pulley, so torque total is equal to T1 minus T2 R. That is our formula. That is our formula. So, what we need to do is take 2,500 minus 500 times 0,4. Now R, now you take the effective diameter. So R is equal to dE over 2. Your effective diameter divided by 2. That's how I got 0,4. So this all adds up to 800 Newton meters for torque. Torque is equal to 800 Newton meters. Right, and our last question. They want to know the diameters of the shaft if it were hollow. And it is 60, now the inside diameter is 60% of the outside diameter. So first we'll need to calculate NE. NE is equal to 0,5 times M plus TT squared plus M squared. Just like that. That is our formula. With the information that we have. So, our D is unknown. Our little d is 0,6 of D. And also, what we need to realize is that our stress is 75 times 10 to the 6. Okay, so what we need to do is calculate from here. So 0,5 times M, which is 1865,5 plus the root of 800 squared plus 1865,5 squared. Let's put that in our calculator and get an answer. 0,5 times 1865,5 root 800 squared plus 1865,5 squared. Okay, and our answer comes out to 1 equals 1947,65 Newton meters. Okay, now to calculate our diameters that we will need. We need to use a different formula, but we needed ME to start off with. So ME also equals pi times d to the 4 minus d to the 4 stress over 32d. Okay, so what we need to do now is ME is 1947,65 equals pi times d to the power 4 minus 0,6 to the power 4 d to the power 4. Always remember that, because d is equal to 0,6d. So always remember, when you're dealing with that, the power 4 goes to both numbers. The power 4 affects both numbers. Times 75 times 10 to the 6 all over 32d. Okay, I'm going to erase. Here. Give myself a bit of space to work with. And I'm going to teach you how to solve this formula. So ME is equal to 1947,65. Right. Okay, so now what we have is, now I'm going to calculate D inside the bracket first because it's odd mass. Brackets first, brackets of multiplication, division, addition, and subtraction. So, odd mass first. So let's do our, so now it's 1 minus 0,6 to the power 4. Then we're still left with d to the power 4. So we've just done this. So what we're going to do is 1947,65 equals pi times 0,87 d to the power 4 equals 75 times 10 to the 6 all over 32d. Okay, now we're going to multiply these two in and divide by 32d. So that stays to the 4, the d stays to the 4 because we cannot change that. So what we're going to do is multiply this in and multiply that in, and then divide by 32, and then divide by D. And then we'll get our final answer for D. So, we're going to take over and under pi times 0,87 times 75 times 10 to the 6 over 32. Okay, so this answer becomes 1947,65 equals 6,406 times 10 to the 6 d to the power 4 over d. Now we cross off that d and cross off that and make that 3 to the power 3. Now what we do is we want d by itself. So 1947,65 divided by 6,406 times 10 to the 6 equals d cubed. Now what I can do is we can do that sum and then cube root it. So we're going to do the sum and then cube root it. So 1947,65 divided by 6,406 times 10 to the power 6 equals. Okay, let's cube root this, because my calculator doesn't go that far, it seems. So, cube root 1947,65 divided by 6,406 times 10 to the 6. 10 to the 6. There we go. And D equals 0,067 millimeters. Or meters, sorry. Goes to meters. Now we have to take 60% of this. So D is 0,6 times 0,067. So 0,67 times 0,6. And D, little d, is 0,04. Meters. So our diameters are D equals 67 millimeters, and little diameter is 40 millimeters. And that is our final answer. And that's the last sum. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I'll enjoy reading your comments. Please use the comment section to let me know what topics you would like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.